So now this is the screen recording that I was talking about earlier. This is now on the system that was live streaming from the camera servers, or rather the system that was the host for the Vicon hardware. And the neat thing about this is that it live streams into, for this example, for the particular plugin that I have, live streams into Motion Builder. So if we have like human objects and we want to kind of create visual performances off of them, we can live stream from the marker data and the solved data that comes in and stream it into an environment. So this is basically a character that's pre-built, and it has its own skeleton setup. So this white bones and the little joints are the bones that are set up for the original character. Yellow ones that you see here are the ones that were the solving bones for the performer that I was showing you earlier. And it's now live online from the original system. And the original system is paused at T-pose. So what I'm going to do is I'm going to go in now and set the original system to play the captured sequence, and you'll be able to see the actual performance that is being live streamed into the system. And also another thing I want to point out is that this is live streamed over a wireless network. So now the actor is being streamed in, and the bones are controlled with the original yellow solving bones from the original capture sequence. And I really didn't spend the time to orient and match all the bones, so a little bit of the motion may be a little bit off, but this is actually a live stream with almost no modifications on the original data. So the accuracy of this system is actually quite interesting. So we can use this for medical applications, engineering applications, applications that deal with assistive technology, and so forth. So so I hope this gives a kind of a demonstration of the capabilities of our equipment. And I will be happy to talk to you about any specific applications that you may have in mind. So next I'm going to go into the server with the Vicon software, and then I'm going to look and open up some of the curve editors and take a look at the raw data that we get, and then see what we can do with those. Alright, so now I'm back in the Vicon system, Blade, and I'm just going to scrub through this animation a little bit more. So these are the kinds of data that Blade generates for us. And we also have another software. It's called Tracker. Tracker is for more for rigid body tracking. And also we have a data streamer, and the data streamer can stream into, essentially it streams out the information from the joints, bones, markers, and so forth, and then we can stream them into either a MATLAB program or a C++ program. So the kinds of data that we get are essentially unlabeled markers, if you have markers that are not labeled, or labeled markers are the ones that are actually attached to, according to the solving models and the bones. Then we also get the solving markers, solving bones, labeling bones, constraints, and a whole bunch of different objects. And in this software, we'll be able to look at certain parameters and items. What I'm going to do is now I'm going to go to the curve editors and see what we can get. Let me just close up these views that we don't need, so I get a little bit of more of a environment to work with. So I'm going to make that perspective. And then depending on which item I want to work with, we'll be able to take a look at its the information off of it. So I just clicked on the right labeling upper leg, and so the RGB curves here are going to show me the rotation, for example, of the leg. Let's see if I can. There it is. So, so as you see, when he moves in, it gives me all the three-dimensional locations, or rather orientations for his right leg bone. And I think these data, this is basically it's just graphing them in. So you can just zoom a little bit more in, and so I'll be able to essentially visualize this data, which is going to really serve as a really nice looking ground truth information. But all this information also streams out as data objects, so we can play with those custom made program, as I said, with like a C++ program or a MATLAB program. So that's one thing. Let me just open up another view. I think I had like one of my students do a little bit of a walk with like, for example, for gait recognition. So this is, for example, a gait recognition, or rather one of the students kind of performing like a regular walk. I'm just going to process the sequence. It's going to take a little bit, so I'm just going to pause the screen capture. Okay, it's almost done. Alright, so now this is the gait, and so let's, for example, let's say, again, if we wanted to look at the right leg for this gait. So that's basically the ground truth data for me that the software generated. And as you see, for example, a little bit of the data is missing, and those pieces are these kind of blue filled in lines here. For example, when the student went out of the view of the camera, right around there, some of the data is missing. So I'm basically kind of interpolating them with like a linear interpolation to fill in the missed data over here, which I think the system automatically does a really nice job of doing that. But in general, it gives me the kind of ground truth that might be useful. And so one of the applications of this system that I had in mind, for example, was setting up the actors to perform several kinds of gaits, and then we record all this data. And this is for like each individual bone, so I can click another bone and it give me a different set of data. So for example, the neck, or the right leg, the left leg, lower portion of the leg, upper portion of the leg, and the feet. And then when we have these information, then we can basically use like visual domain, like for Kinect, and then utilize the skeletal reconstruction from the Kinect and map it with the actual reconstruction we get here, and try to train a system that can be much less expensive, using like just a visual markerless motion capture system, but getting the actual training coming from much more of an accurate system. So so that's one kind of an application that I think might be an interesting thing to look at. Let me just open up another gate, and this is when I gave the student for this next gate. He is actually now wearing a relatively heavy backpack. All right, I reconstructed now his gait with this particular setting, so he's now wearing a relatively heavy backpack. So, and then we had him walk. And so we can see just minor differences even visually in his seat. So right here, he's in his T-pose, and then he walks out, and then we have him put the backpack on, and so it's just moving around. So this big patch of movement on his right leg, upper leg, is when he's doing the movement. And so as you see here, right around here, I missed a little bit of the data because that's where he's moving a little bit out of view, but that doesn't really impact negatively my curve. So then we had him move, and so now as you see, his gait has slightly different. So unfortunately, with this software, I won't have any mechanism to show these gates side by side, the differences between the two gates. But visually, I can see there's a little bit of a difference in his walk pattern. So so that should be a relatively nice basis for a study. For example, for gait recognition and things of that nature. So this is pretty much all I had in mind in terms of a little demonstration of what we can do here. And as I said, we have two other kinds of software packages here. A streaming software, which basically streams out all this information in like an audio stream, and then we can feed them into a C++ or a MATLAB file, and then also a tracker software. And the tracker software does pretty much the same things, but it does it for rigid objects, like for example robots or props. Like for example, if this actor were to pick up a gun or pick up a hammer or something like that. So thank you for listening and watching this kind of rather long video. And I apologize for the length of it. Just wanted to try to cover almost all of the things, and hopefully to give you a better idea about the system. Alright, well thank you so much, and I look forward to talking with you again and hopefully establishing a productive collaboration from this point on. And I appreciate your patience. Thank you so much. Bye.